professor of water resources engineering at Delft University of Technology in the Netherlands. And we're also part of the board of TAMO, the Trans-African Hydrometeorological Observatory. Started in the Netherlands as a foundation, but now TAMO is mainly in Kenya, but covering all of Africa. TAMO tries to build a network of thousands, let's say, of weather stations in Africa. At the moment we have over 600 stations in about 20 countries. And we're trying to really maintain the network and to grow the network and also ensure that the quality improves of what we have. It's not easy to run weather stations, to be honest. It sounds simple enough, but it's quite difficult. We put most of the stations at schools where they are also part of the curriculum, which we like a lot because we're all educators involved, all the people involved in TAMO are educators. And we're trying here now at this workshop to see if we can use this TAMO data to combine them with satellite observations to make a much broader, much more detailed rainfall product.
My name is Miguel Averde. I'm researcher at the Asian Disaster Preparedness Center in Bangkok, Thailand, under the Service Southeast Asia project. Right now we are working on have a better understanding on the extreme weather events and especially how we're able to monitor and track them in extreme scenarios. So one of our goals is to create a system that we were working in the area of the Mekong that we developed. It's called the Rhestom Tracker.
My name is Doreen Lucht and I'm from the Netherlands. We're working on precipitation measurements from satellites together with TAMO stations. We are working with Meteosat, second generation satellite, and this is a satellite that measures at really high temporal and spatial resolution. Which is important, for example, in the case of flash floods, which happen a lot in the urban areas here across the continent, because those floods, they develop over a very short period of time. And you want to have the most recent information to be able to predict a flood happening. There's a huge need of precipitation measurements, ground measurements, and that's why the TAMO project has started some years ago to place stations all across the continent.
We have a TAMO dataset from 2015 to 2022, and I have to make sure that everything, all data is reliable, that we can use to make a final product.
So I'm Jacqueline Wamboyo Wangombe, working with Tomorrow now. One of the amazing things that I've got to learn in this workshop is that there's so many products out there that can be used to make weather data much more better and come up with more realistic prediction, especially when it comes to weather.
Hi, my name is Philip Frost. I'm the Director of Agricultural Climate Resilience for a non-profit called Tomorrow Now. The opportunity within this workshop is for us to collaborate with TAMO as well as with the University of Delft into new methodologies to improve regional observation network data and utilizing observation data in a way that we can create bias corrections and calibration and validation of both modeled as well as satellite rainfall products. But once again, all of these satellite products require support from ground-based observations and require continuous calibration and validation on the ground in different environments, and that's why it's really critical that these kind of workshops bring together public-private sector as well as universities to be able to develop new methodologies to improve our ability to calibrate and validate data for the region.
And I'm working on a project which is about merging several rainfall data. So there is a method that has been developed to merge several satellite-based data, and here we want to use TAMO, like this station, to bias adjust and have a final product.
TAMO has been running for a period of more than 7 years. So with all this data that we collect and with all the feedback that we get from partners and med agencies, we're here to review, to see what is working, what is not going according to plan, and also to look at other products that are existing, say satellite data. Part of what we're looking at also is how to use this data in the area of storm tracking.
My name is David Joroge Mburu, that's my full name. I used to work for the Kenya Meteorological Department. I am a meteorologist by profession. I am a friend of TAMO. This very sophisticated science of meteorology, how does that translate into productivity to the farmer who is in the rural areas? TAMO, as of now, is developing low-cost but very sophisticated sensors, which can be deployed, and some of them have already been deployed, so that data can be able to be availed because measurements have to be done. Why is there a problem of sustainability of all these weather stations in Africa? The value of meteorological data actually cannot be overstated, but it is enormous because there can be several users whose businesses can achieve higher value through this provision of this weather information.
My name is Dennis Mothike, and I'm a climate scientist. I work with a regional institution called the Regional Center for Mapping of Resources for Development. We are based in Nairobi. We work across 20 countries in Eastern and Southern Africa. How best can we utilize data that is available in Africa to solve developmental challenges, including challenges in water resource management, in disaster risk reduction, challenges in prioritization of investments and funding for climate adaptation? The key focus of this meeting is to find ways in which we can improve satellite remote sensing data with ground measurements using rainfall, or broadly weather stations that are managed by TAMO network across Africa. And it is important to recognize that data continues to be a challenge for climate research in Africa. We're hoping that by the end of this week, we'll have had sufficient insights for us to be able to drive then the next level improvement, which is bringing in the TAMO station into that rainfall precipitation retrieval model that is already available from Meteosat.